Yeah, I'm good.
Good evening, everyone. I want to welcome the members of the Denver Council on Foreign Relations here tonight, and also our guests, and also those who are joining us online tonight. We really appreciate you being here. I hope you had a good meal. I am Robert Lance, and I am the president of the Denver Council on Foreign Relations. And I just want to thank you all for coming, because I think tonight you're going to learn a lot. Our speaker tonight is Ted Scambos, and he's here to discuss Antarctica and the global sea level rise. We also have the pleasure and privilege of having Leilani Henry, who's the author of The Call of Antarctica, here tonight. And there's going to be a lot of information downloaded, and I'm looking forward to questions at the end. But I'd like to, without further ado, I'd like to introduce Barry Berman, who's actually going to introduce our speaker tonight. Barry Berman has been a friend of the Denver Council on Foreign Relations for a number of years, and is a friend of mine. He has a consulting company that helps people get better in life. So that's how I'd say it. Come on up, Barry.
Damn you all to hell. That is what, what's his name? Charlton Heston, do you remember that? And Charlton Heston said that at the end of Planet of the Apes, when he discovered he came back from space and discovered he was always home, and we had destroyed our planet. So we're going to have a conversation about where we're heading, right, Ted? And in my view, it's kind of like an almost certain future. You know, you never can predict the future for certainty, but it's an almost certain one, and there are some opportunities for us to make a difference here. So I wanted to introduce Ted. We've known each other for 3,000 lifetimes at least. Ted Scambos is a senior research scientist at the Earth Science and Observation Center, which is a part of the Cooperative Institute for Research and Environmental Sciences at the University of Colorado Boulder. So among his research interests are climate change, impacts on the polar regions. He has studied the collapse of the ice shelf areas and glacial acceleration in the Antarctic. He's been there, what is it? How many times have you been there? 21 times. I can barely think about going there once. It's so cold. A major focus of his work now is developing instrumentation to try or better monitor and understand the Antarctic climate and ocean circulation in areas of major change. So he has a master's degree from the Virginia Polytech Institute, State University, and his PhD in geology from the University of Colorado in Boulder. And for 14 years, he's mentored 6 PhDs. And MS students. He has been on 21, that's right, expeditions to Antarctica in every region of the continent and the sea ice that surrounds it. He was part of the international scientific team that had crossed the Antarctica by tractor traverse in 2008, 2009. That's really something. And I think you had something to do with discovering the breakage of the ice shelf somewhere in the Antarctic too. I did mention that. And he's co-authored of more than 150 scientific articles on his research with funding from NASA and NSF. And he's been interviewed by CNN and ABC and various organizations. So he's well known in the field and he has a lot to share with us. And so I think if we don't screw it up in Russia and Ukraine and we get this in, we might survive. But I'm a Jewish pessimist too. So I want to introduce Dr. Ted Scambos. Thank you.
Wow. Thanks a lot, Barry. Barry and I have lived in the same neighborhood for 25 years, and our houses are the ones with big solar arrays in front and big backyards for growing things and yeah, enjoying life. Yeah, that's great. Well, yes, as Barry said, I've been to Antarctica many times. I've been all over the continent. We're going to talk a bit about Antarctica and sea level rise. We're going to talk in general terms. I'm also going to take you on kind of a tour of Antarctica because having been there a lot, I've seen quite a bit of the continent. It's beautiful. And I think you'll see at least some of what the landscape looks like. And then we'll dive into about 10, 12 slides on the science. I'm not going to hold back. There's going to be some interesting stuff to show that has to do with the research that's going on. I am the Science Coordination Office Principal Investigator for a project that has about 100 researchers in it studying this glacier, the world's largest unstable glacier. It's called Thwaites Glacier, Thwaites, and we'll get to that in just a minute. Those blue dots are all the places that I've been to on the continent. I've crossed it, as Barry said, from the South Pole out to the coast. I've been to some of the highest and coldest areas on the continent in the East Antarctic. I should point out a little bit of geography in case I slip up and don't tell you sooner. This whole right half of the continent, I'm not seeing that very well. The whole right half of the continent there is called East Antarctica because it's the part that's in the Eastern Hemisphere. And then the part that's sort of smaller and on the left or slightly lower left is called West Antarctica. And that's the part that's really quite dynamic and active. And I'll show you why. Barry mentioned looking at how ice shelves break apart. And that has to do with the Larsen ice shelf. And also as an experiment, what happens to icebergs when they drift into a warmer climate? Not climate change, but it simulates climate change. So it shows us what happens when floating ice gets too warm. Most of the continent looks like this, just miles and miles of these sculpted snow dunes called sastrugi. Basically, the wind is blowing, a little bit of snow falls, but it gets worked and reworked into this sort of frozen ocean shape. And then near the coast is quite spectacular. You really get the sense of a mountain range that's trying to emerge from a blanket of ice, lift its way out. And you also get a strong sense of flowing ice and how how ice is in motion all the time near the coastal and near the mountain areas. When we crossed Antarctica for days and days and days, it looked about like this. Those other two dots in the distance are other traverse trains like the one that you can see in this image. So we were spread out for over a mile, driving for about 2 or 3 months across this wilderness. And we would stop every once in a while, drill a core, set out some other instruments, and then keep moving. Now around the coast, the ocean actually freezes mostly in winter. And that takes on a variety of forms. This sort of plate glass stuff has a name for it called nylas. But then, oops, I skipped one. Oh, just keep going. That's the East Antarctic Plateau just before we quit for the season. The temperature in that image is -47. we had a lot of trouble starting the vehicles and decided we needed to get down off of the plateau. So we drove for 48 hours and got down lower to a base nearby. There's a lot of wildlife around the coast. The interior is almost bereft of any sort of living thing, but around the coast is quite lively. The ocean is quite productive. This is a Waddell seal warming up for the summer. A minke whale here breaching. One of the smaller mid-sized whales that are actually recovering quite nicely from overhunting earlier on. And of course, penguins. There's a number of species of penguins. These are called chinstrap penguins. They've been made famous by the movie Madagascar, the sort of military looking ones. That's a typical camp that I might be in the middle of Antarctica. Okay. And you'll see that larger tent looks sort of rainbow or multicolored. That's our main cooking and working tent. And then the other triangular tents, that's actually a design that goes all the way back to Scott and his men crossing Antarctica and reaching the South Pole. That is actually still called a Scott tent. They're very effective in the wind. You cannot blow them over no matter what. And that little pup tent is actually our latrine. So inside, we've got a cooking area on one side like this. You can see some actual Primus stoves. They still use those in the British program. This camp was with the British program. And then it's not too uncomfortable for 3 to 5 people in there. On the opposite side of the kitchen, we've got sort of a sitting area. There's usually a lot of clothing over there, computers, ways to charge up batteries. There's several radios in that picture. The white thing in the center is a satellite phone radio antenna. And there's shortwave as well. We still use that. This is kind of an example of what it's like on a day. I'm going to warning you, it might be a little loud on a typical windy day in Antarctica when it's a little bit too rough to work. It's not all that loud because the sound is only coming from my computer. Someone is trying to sleep in there, actually. And we built that wall behind it to keep the tent from getting buried and crushed. We had a tent that we were using just for charging different electronics, and it actually did get overwhelmed by the snow and crushed. Another issue with the weather. Okay. I already talked that one out, did I? Another issue is the weather. We can get these whiteout situations where there's low clouds and thick clouds overhead. The sun is shining, but everything is quite reflective. And so you're really afloat in this sort of gray oatmeal. You can't see anything. And there is a tent. There's that colorful tent in this picture. And Aaron Pettit, my colleague, is pointing to it. I think you might be able to see it if you look really hard. On the right side, there's just a few little patches of color. We're only about 50, 60 yards away from it. So you can really see how people can get lost there. So there's the continent again. I mentioned East Antarctica, the big sort of oval area occupying 2/3 of the right side of this. And then that smaller, somewhat triangular part on the left side, that's West Antarctica. The Pacific Ocean is sort of on that left-hand side. South America is off the tip of that long, skinny peninsula called the Antarctic Peninsula. Australia is kind of off to the lower right there, just to get your bearings. Now, after dozens of years of trying to map how thick the ice is using airplanes and people crossing the continent, we have a map of what the continent looks like with the ice completely removed. And this is the start of the story of why a particular area is the riskiest glacier on Earth. So you can see that East Antarctica, with the ice removed, is still mostly above sea level. All the yellow is above sea level. And in fact, if you were to let the continent rise up without the weight of the ice on it, would actually look about the size of Australia and about the same terrain as Australia, mostly flat, just a few mountains, although there are some bigger ones here, and mostly above sea level. There's only a few patches in East Antarctica that are below sea level. But West Antarctica is very different. It's really more of a cluster of large islands with very deep troughs. All that dark blue in there is actually ocean seabed, but it's been buried under ice so thickly, the ice is now piled up high above sea level. if that becomes unstable, then that ice that's piled above sea level, just that fraction of the ice, that part contributes to sea level. The problem is that because the ocean is so deep underneath the ice, it makes the ice unstable, inherently unstable. And you can see that there's sort of shallower area in between those two large islands, sort of on the lower left towards me. That's where Thwaites Glacier sits, and that's sort of a gateway to this very deepest, thickest ice in West Antarctica. So here's the most recent estimates of what sea level rise is going to be like over the rest of the century. And what you can see is a number of scenarios depending on how active we are in terms of controlling CO2 and methane in the atmosphere. So all of those that have the acronym off to the right side are different scenarios of, how we address climate change. But there's a dotted line flying above it. And that is the line that the IPCC has said, we're still not sure how unstable the ice sheets on Earth can be. And if we go down the wrong track with a lot of CO2 and a lot of methane in the atmosphere, and some of these processes that I'll discuss later, just a minute, take hold, we could see sea level rise over a meter before the end of the century. And at the end of the century, we could see sea level rise rates of up to 30 millimeters over an inch per year. So we need to get our minds on this problem and understand what the real forecast is, because this is just really an estimate of how bad it might get if the worst case scenarios, both in the atmosphere and on how the ice responds, take hold. And so it's something we want to try to avoid. Now, here's another picture of sea level rise just in the last few decades. And what you see is that there's a couple of components to sea level rise. Some of it is just the ocean getting warmer. I've labeled that heat under there. And some of it is contributions from the ice sheets in blue. When you put them together, you see how we had an increasing sea level over the last 20 or 30 years. And in fact, although it's not easy to see in that plot, it's accelerated over that period of time from about 2.5 to 3 millimeters per year to over 3 millimeters per year now in the most recent decade. You can also see that map of the average actual observed sea level rise from satellite data. And there's a lot to what happens on a particular coast for sea level rise. There's wind shifts, ocean current shifts. Those are also tied into what we're seeing in terms of climate change and changes in the Pacific Ocean, changes in the oceans in general, as to how this water gets redistributed across the ocean. So it is not as simple as just having the bathtub fill up more around all of the coastlines. There's a lot going on with local weather and local conditions. Now, have we ever seen sea level rise this fast in the past? Yes, we have, and not all that long ago. At the end of the last ice age, there were a couple of centuries where we saw rates of 40 to 60 millimeters per year. And that almost certainly comes from the decay of the ice sheets, the much larger ice sheets that were present back at the end of the last ice age. So the point with this slide is ice can do this. We really can see a transformation in terms of sea level within the space of a few centuries. And it also shows that the last 8,000 years, which if you think about it, that's the entire history of human civilization. That's the invention of agriculture all the way to the invention of the internet. And it has been extremely stable. We've had it so good for this whole period of time. And yet now we're jamming on this button that says ice is going to, start to melt away and add the sea level again. There'll be massive changes associated with that. So using satellite data again, we have a way now of mapping in good detail exactly where in Antarctica we're seeing ice loss. Now, this particular map is colored for elevation change. So if the surface is deflating over time, that means that there's snow falling on the surface, there's ice flowing. If the net balance of all of that is to lose ice and the ice elevation drops, that shows up as red. Blue are areas that are gaining thickness in ice. But I do want to point out that the scale at the bottom shows that you can gain in thickness a little bit, but the areas that are bright and dark red are losing ice much faster. And so overall, Antarctica is losing about 150 billion tons per year, or about 0.4 of a millimeter of sea level, which you can't even hold your fingers apart and still have them measure 0.4 of a millimeter. But every year it gets a little bit worse. It is accelerating in Antarctica. And back 30 years ago, it was only about 50 billion tons per year. So it's tripled since then. Now, those red areas are the areas to be concerned about for sea level contribution. Thwaites sits in the middle of pretty much the most responsive part of the ice sheet in terms of how it's reacting to climate change. This is a movie right there in the Thwaites area. This is actually where I was for a few days just last January, repairing some instruments, and those two colored X's on the ice are where the instruments were. Now, this is a movie that's been acquired over the last 7 years of what's gone on in this area, and you're going to see it flow and crack a lot. And if you look really carefully, you'll see that the cracks sort of move upstream over time. They reach, the new cracks form further up and further up. That red line marks the line where the ice first goes afloat. I'll see if I can't redo that. So you can see how the ice is just tearing apart. You can also see some huge sharp cracks next to the red X and the green X that form on that plate of ice that's floating on the ocean. So the red line marks grounded ice that's resting on seabed, and that continues for hundreds of miles inland. And this is where the ice meets the ocean. You can see that there's a lot of breakup and deformation that occurs right in this area. So why is this happening? And why are the two areas in Antarctica that are changing a lot? That's the tip of the peninsula and this area called Thwaites. Why are they the ones that are getting the most action? What's happening is that those large blue arrows indicate a pattern of wind that surrounds Antarctica called the westerlies. Or sometimes you may have heard of the west wind drift, which is the ocean manifestation of that wind. The wind blows over the surface of the ocean. The entire ocean is also moving in that from the west to the east direction, a westerly wind. Over time, as the Pacific in particular has gotten warmer due to climate change, those winds have gotten stronger. And as they get stronger, they tend to contract a little bit close to Antarctica. Pardon me. And they also push the surface water out and away from Antarctica. And that's the problem. If you push the surface water out, then you bring in warm water underneath to replace it. So there's melting touching the continent at depth, pardon me, in a place called Pine Island Bay. And then there's a lot of surface melting that has to do with Chinook winds. We're all familiar with Chinook winds in Colorado. They happen in Antarctica too. And that causes a summertime melting in that area that has actually caused some ice shelves to completely disappear. Now, I just want to get into a little bit more detail. So you're looking at that other cross section where it says Thwaites. I'm not sure why it says WC. Wind, I'm not sure. Anyway, west cross section. The easterly and westerly winds. So that easterly has an X on it, and that means it's going into the page. The westerly winds are coming out of the page at you. And what happens is both of those winds tend to push water away and to the left. But when you combine those two, it lifts. Sorry. I guess I do, yeah. It lifts the warmer water at depth. Thank you very much. It lifts the warmer water at depth where it sloshes onto the continental shelf, and then it flows down towards the continent where it engages with the ice sheet. So that's the problem. That's happening more often than it used to. That's happening more often than it used to because the Pacific has gotten warmer. The Pacific has gotten warmer because the atmosphere is warmer from CO2. This consequence of adding CO2 to the atmosphere changed the Pacific, which is a huge area of the Earth's surface. It's changed the wind patterns around Antarctica, and it's led to warm ocean water reaching the coast of Antarctica and melting up to tens of meters of ice from the underside of the continent every year. So I'm going to show this again because this is kind of a reason why Thwaites is the focal point. Again, not just it's a large glacier, but it's a large glacier that straddles some of the deepest bedrock in Antarctica. Not only that, but you can see that it has a sort of a central position in West Antarctica. You can't remove this glacier from the middle of that ice sheet without drawing ice in from what's now a part of other adjacent glaciers. So Thwaites is in a kind of a keystone position within the West Antarctic. Now, a process that would really draw in a lot of ice or deflate Thwaites completely will take centuries. I want to make that clear because that didn't get across in this press release at AGU. What I'm talking about are the very first stages of a process that will take a couple of 100 years to play out. And it will take longer if we're good about controlling how fast the Pacific gets warmer. This is a rather complicated but pretty cross-section of all of the processes that are going on. And we're trying to understand all of these things with this International Thwaites Glacier collaboration. Several projects getting together, and they're all international. They have a US and a British component. And then collaborators from Sweden and from Germany and from South Korea. All of those groups are studying different aspects of the glacier. So that whole area that I showed you that disappeared when I took away the ice sheet, people are working on every aspect of that. In two cases, Prophet and Dominoes at the top, it's modeling studies that are trying to understand both the future of the ice sheet in more detail than we have been able to model it up to now. And then this Dominoes project, sort of cleverly named, it's about how the ice front collapses and calves, sometimes like cliffs, like dominoes falling off of a cliff. So I'm responsible for two of those stations just above the words melt and Tarzan. It says through the ice moorings. And what that means is a weather station that's also tied to instruments that go right through the ice and into the ocean below. And we'll show you a picture here of one of these stations that we built at University of Colorado. It has a computer system and a GPS there in the lower left. It's on a tall tower because that's about 3 years of snowfall. So it stays out of the snow for about 3 years, with the battery box at the bottom full of 6 large car batteries in order to power it, as well as solar panels, 4 large solar panels to keep recharging those batteries. So setting this up is kind of a big deal for a small field team, but all of us together managed to get it done with some help from ropes and pulleys. And those things have been working for 2.5 years now, sending back data on both the ice and the weather and the ocean below it. So those 2 stations are called cavity and channel after surface features. And they're showing you, those arrows are showing you which way the ocean is moving at depth below this area of ice shelf. Now, this map is turned sideways a little bit from the one that I had that was sort of gray and showed the flowing and cracking from 7 years of satellite data. So it's turned a little bit, but you might be able to recognize the pattern again. This is the area that's been breaking apart and flowing rapidly over the last few years. So that breaking apart aspect, this is a glacier in Greenland, but it's giving us an example of a process that we're quite concerned about, which is very tall cliffs fracturing rapidly off the front of the ice sheet. So as Thwaites begins to retreat and these pieces crack off, they can leave a taller and taller cliff of ice sticking up out of the ocean. Ice is not like granite or even hard sandstone. It's a relatively soft material. It either bends or it can be quite brittle. It's just not as strong as rock. And the problem is that you set up a cliff that's maybe 300, 350 feet tall, it will fracture immediately. Well, that's not impossible with the geometry at Thwaites Glacier or at this glacier, Helheim in Greenland. Helheim is much smaller, but it does provide us with an example of this process. Another glacier is up in the peninsula called Crane Glacier. It too is showing this sort of high cliff fracturing process that makes the glacier retreat rapidly. So we're quite concerned about this because the models are showing that if this really takes hold, then you're going to get a lot of ice breaking away within, in this particular model, with the geometry set properly, just 22 days, basically, you've lost several kilometers of ice. The lower one is a little bit more like Thwaites. It does take a bit longer. And you can also see that the whole ice sheet is deflating. You see that dotted line on top emerging above the ice. it's thinning gradually as it's losing these pieces of ice. This is a computer model, but it incorporates everything that we've seen about fracturing and about ice flow at the same time. And it's really kind of transformed our ability to predict where and when this sort of a process is going to happen in the future. And that's the path to getting a better forecast for between now and the end of the century for what this glacier is going to do. That's really the goal for the International Thwaites Glacier Project, and something that we're working on right now and for the next couple of years. We have about 3 more years to go on this project. Now, I'm going to segue to some Antarctic history with my friend and co-speaker, Leilani Henry. She's going to tell us about a fantastic experience that her father had 70, 80 years ago, 90 years ago.
Well, I'm just taking in the video of the ice melting. And it's pretty daunting. So my father, George Washington Gibbs Jr., was with Admiral Byrd on his expedition to fly over what is now known as the Thwaites Coast in an airplane and map all that coastline. It was the 3rd expedition of Admiral Byrd and the 1st expedition of the United States in 100 years. So that's my father, George Washington Gibbs Jr. This expedition was, okay, all right. This expedition was in 1939 to 41. And Roosevelt commissioned Admiral Byrd to go. He was going to go by himself because he'd already been doing that for a couple of the expeditions. But they wanted to keep an eye on the Nazis, or on the Germans, in 1938. And they didn't know what the Germans were going to do in Antarctica, and they didn't know what they were going to learn. But they thought, we want to just keep an eye, just in case. It turned out that the Germans weren't really doing anything. They thought maybe they would make a base and establish something there, but they ended up not doing that. And in the meantime, this expedition, my father was 22, 23, and he sailed on the USS Bear, which is one of the most famous ships now in the United States. And they just found the ship at the bottom of the ocean near traveling from Nova Scotia on the way to Boston. They were going to make it into a restaurant. And the ship was like, no, I'm not doing that. But they just found it under the ocean, which is quite exciting. So Ted wrote the foreword of my new book, copyright 2022. And it is about a combination of climate change, the history of my father's story, and his diaries. So I inherited the information when he passed away. He was going to write a book, and he never did. And he kept saying, well, I don't know if I have enough information to write a book. Like, well, if you don't have enough information, then how am I going to do that? But we found his diaries in the back of the dresser after he passed away. He wrote every day for 6 months on the Bear, started from Boston and did round trip to Little America. And then they came home. So this was the 22nd of November of 1939. And then they were back in Boston, June 1940, home for a few months, and went again from Philadelphia round trip to Little America So it's quite exciting. This ship was 66 years old, a 66-year-old wooden ship that they didn't think would get out of the shipyard. And of course, Admiral Byrd got it out of a museum, paid $1 for it, got it recommissioned because that was the ship that he was the most confident in. So those are some of the facts about the expedition. No one died, which is very important in Antarctica to have everyone come back. So part of the discovery was Thwaites Glacier also. So the two ships, one was the North Star, which was a fairly new ship. And of course, most of the officers got to be on that ship. And then the Bear was the other sister ship. There was never a dull moment. There were about 60 dogs on the Bear that never stopped howling. And he wrote some point in his diary that it's so quiet. And the motor stopped and the dogs were stopped howling. And it was just one of those moments, memorable moments. So I could write a whole book about my research. I started doing this 20 years ago. And I didn't know anything about Antarctica. I didn't know anything about my father's experiences because I was a little kid. He was an older father, like a grandfather. So I wasn't listening to his stories. So it's just ironic that I just spent this whole time trying to understand what it was all about. So part of what happened was I met someone on an airplane who ended up introducing me to a friend, and I finally met Ted. And I got phone calls and emails from all over the world congratulating me on my article that I'd written and inviting me places. The first place I went was Jim Richardson in Claiborne, Maryland. And it turns out that his father was on the ice. And so one of the jobs of my father and the crew were to drop off the scientists, build the base. They built the west base and the east base underneath the ice. And so Jack Richardson was down there, and this is a hand-drawn map. So Thwaites Glacier was over here somewhere, and then Little America was on the other side. And his rendition of, because they did much trekking and exploring during the year on the ice. So we found that in his files.
West base is known as Little America, where it says probably it's Little America more than Little America.
The other exciting thing was that because this was the first place I'd gone, Jim Richardson had trunks, and of course, a lot of it was moldy or smelling because of, he lived on the ocean. And so I'm digging through the files, still pretty clueless about, I know that my father said he went, but I couldn't find any information in the National Archives, the Library of Congress. So I thought, well, I know he went, but did they not document because he was Black, or what happened? And so I'm in this house and we're looking, and I find this letter that says, "Dear George." I'm thinking, okay, "Dear George." And then at the end, it had some sort of joke about Black Huskies. And my father had a great sense of humor. So I thought, well, it kind of sounds like a letter maybe written to my father. And then we dug a little more and found the first picture. I'd seen any pictures outside of a couple that he had in his files growing up, the first picture, and it was my father. So the first place I went, the first person I talked to, and they were actually friends. So he was writing to my father from the ice, which was a pretty big deal. So the reason that Admiral Byrd wanted this ship is because it would go through the ice better than anything else. And so that's, as you can see, you can imagine trying to get through. They were stuck several times. There were a few times when they thought that their lives were lost. They were just going to ended up like not like Shackleton, but yeah. And or Scott, not coming back. So he befriended the Huskies because his friend was the dog driver. So that's a great photo. And then the other one is the snow cruiser. And the snow cruiser was a very famous machine that was going to be the third base. And they threw that together and got it down to the ice. And it had bald tires, among other things, and they never could use it. So that's a whole nother story. Ted actually has done some research on the snow cruiser. We want to go find it under the ice in a couple of years and make a film about that. Yeah. Yeah. Not showing up. Next one. Oh, there it is. Okay. No, I wanted to show. There we go. So one of the reasons so I'm interested, I'm a leadership consultant. I'm very interested in leaders, how they lead, how people work with them and feel included. And so one of the things about Admiral Byrd is that everybody loved Admiral Byrd, not necessarily his peers, but the people who worked for him. And so Admiral Byrd and then Captain Cruzen made sure that the burn of Jim Crow was not on the ship. So my father was one of 3 Black men on the ship. He proved himself to be outstanding and was treated as such. He had a couple of medals for meritorious service, for zeal and courage. And to this day, I'm not exactly sure what he did. I'm writing a play, imagining what might have happened. And there were a couple times in the diary where he said, there are a couple people on this ship that wouldn't want me here. And he wrote this in April. So from November to April, there were still issues of being included. But for the most part, the captain and the admiral were very conscious of this during a time of segregation where people weren't used to being together of different races. So they managed that pretty well. And so my father, there's a school named after him, George Washington Gibbs Junior Elementary School in Rochester, Minnesota. That's where I grew up. There's a street named after him. You know, the Mayo Clinic is in Rochester, and there are no streets named Mayo Clinic or Mayo. So it's very interesting that he took the leadership that he learned about and experienced in his 20s and all the way. He died when he was 84 on his 84th birthday, and is very admired in the community because he helped others be included in Rochester, Minnesota. Couple more slides. So here's more on the expedition. One of the things that was very exciting is that he realized in other parts of the world how he could belong, and race was not an issue. So these were South American sailors that were hanging out on the ship. When they celebrated, when they went back to South America, all of the crew, all of the captain and the admiral, everyone was together. And he wrote, you know, if this was America, this wouldn't be happening. So the seed was planted that we don't need to live that way. And he lived his life making sure everyone belonged. And then this is Little America. Very interesting to see. I think we have a picture of the east base without any ice, but think about that everything was underneath. And they built the tunnels so that you could live comfortably down there. And then the ventilation, so they didn't end up like Admiral Byrd alone, getting asphyxiated. And then that's the east base, but that is the same idea, that when it's covered with ice and everything is connected by tunnels. The other thing my father did that was very smart was that he had an autograph book and he got everyone's autograph. He also took that photo. So I didn't know that he was a great photographer growing up. I didn't understand that, but a lot of his photos are really high quality. And also this was a Navy expedition. And so they had to hand in a lot of their he had to hand in all his negatives. So he took 200 pictures, negatives, and the Navy has them. And nobody knows who did what because they're all together. But he was able to save a few photos, some of the ones that I showed you, because they had a little dark room on the ship. And this one, in my book, there's quite a few pictures of art. One of the things about art is that every explorer from the very beginning had an artist. Now, of course, when they first went, there were no cameras, so they had to document. But even when there were cameras, the artist came and really helped people understand how beautiful it was. And of course, the early images, photographs couldn't photograph the sublime colors that you see down there. So Leland Curtis was the artist aboard the Bear, and my father also has his autograph. Well, he's from Denver and went on to do many, many paintings. And this is extraordinarily beautiful. And I ran it down in California, Laguna Beach at the museum there. And yeah, just art. So part of my interest in this is STEAM. So science, technology, engineering, art, and math, which is becoming more of a thing now. So I think that's all we have time for, but.
So now we have time for questions, if anybody has any questions. Go ahead.
How did your father start in this journey? What was his entry point and why?
Yeah.
What's his background?
Well, he was in the Navy. He lied about his age and got into the Navy early because during the Depression, things were tough. And he went to the civilian corps camp for about a year and then joined the Navy. And after 4 years, he thought, well, I'll just do civilian life, and found out that because of Jim Crow, that was not a very good life. So after 89 days, he had 1 day left to enlist. He went back into the Navy and said, well, I'd like to go to Spain and help with the Civil War. And they said, well, sorry, we're not doing that, but would you like to go to Antarctica? And he didn't know anything about it, but he was up for the challenge. Yeah, thank you.
I guess.
My mic is.
So Ted, I have a question about Pine Island Glacier, and I know that there was a big project down there studying that's right close to Thwaites. What is happening with Pine Island right now?
Pine Island was considered really one of the first glaciers that we could observe the accelerated. Started in the 80s and 90s, actually. And then there was a large effort to study Pine Island, put some instruments on it, work on the remote sensing more. As modeling has gotten better, it's been recognized that Pine Island has reached a kind of a sort of a steady state. It's losing ice. It was part of that red patch that I showed in the satellite data, but it's going to deflate rather steadily, and it's more bounded by high ground. It's still all beneath a thick layer of ice, but higher areas of ground underneath the ice. So it doesn't have as ready an access to the rest of West Antarctica as Thwaites does. And so that's kind of why both the UK, which also surveyed Pine Island after the US program did, like the UK and the US said, really what we need to be looking at is Thwaites Glacier. That's the one that has the greatest potential in the near term, still, again, the next century or two, for really changing sea level.
All right, I've got the mic. Anybody else? This is a quiet group tonight.
How often are your expeditions?
There. So,
Just so I can repeat the question, how often are your expeditions there?
yeah, let's see. In 30 years, I've been there 21 times. Now that number, in some cases, I went down twice, early like September, October on a ship, and then came back and went back to the ice in January and February. So roughly a little bit more often than every other year. Yeah.
Why don't we talk a little bit about why we're doing this together
Oh, well,
in the Thwaites?
yeah. After we organized this Thwaites project and got the 8 different research groups funded, they also funded a 9th group called the Science Coordination Office, and I'm the lead PI on that. There's a British counterpart. Let's see, and we were charged with making sure that both the science got done, that people worked together across the different groups, and increasingly that there was a sense of cooperation and a push towards greater diversity and inclusivity, because polar sciences, quite frankly, are pretty monolithic in terms of what demographic is down there. Now there's more women than there used to be. Back in the 70s, it was actually considered either bad luck or against the rules to have a woman go to Antarctica, or both. And increasingly, there's been more and more of a presence for women in the ice. That's great. But in terms of diversity of race or ethnicity, not so much. And the Thwaites Science Coordination Office took it upon itself to start emphasizing this more among all of the groups. And we formed a group now called IDEA, which stands for Inclusivity, Diversity, Equity, and Access.
Ability.
Okay. And we're working in the direction of, it changed its name. It was JEDI, which I liked a lot better. Justice, Equity, Diversity, Inclusivity. But there were certain issues with it being Star Wars knights and sort of certain carrying weaponry, that kind of thing. But you'll never get a more diverse group than the Jedi Council. I mean, you look around the room there, and that's a very diverse group. Anyway, so.
Can I add?
Well, sure, absolutely.
So-
I was going to say, we started looking for a consultant, an advisor. I said, I know the perfect person. I'm not going to help you pick 3 people, but I know who's going to win. I'll step back. It was Leilani, and it's been wonderful to have her on board.
Well, I have my mic. So
Okay.
one of the things we're doing is helping the people on the ice have a culture of belonging, have a positive work culture. And it's the first time, because they never have time, right? They just go down and just get to work. The first time that they really talked about, well, what are our values? What are our agreements? What are we going to do if we don't get along or if we have conflict? So really setting a tone for having good science and a positive work culture. And that in the interest of recruiting people of diverse backgrounds later on, that happens when you have a welcoming environment. And one of the things that attracts me about Antarctica is that the stories are about people who work together in a way that you don't necessarily find here, back in the States or back in the, what do you call it, above Antarctica. So there's a special world down there. And so how do we duplicate that and bring out the best of human beings? So that's one of my interests.
It's called the real world.
It's the real world, yeah.
All right, I've got one question from outside, since we're on Zoom. How would failure of the glacier affect the coastlines of various countries?
Oh, boy, I memean, there's a lot of countries. So there is a slide that I have that's kind of interesting. I showed the slide earlier that's actually after this last one here. That takes a little while to explain. And this is probably the best way to answer this question. So you saw a map earlier, I know it was a while ago, and it showed different red patches and yellow patches, and there's sea level rise generally, but some places more than others. And I said winds and currents are changing. Now, okay, we're going to go on a little imagination trip. We're going to do a thought experiment, as Einstein used to say. If you were to set foot on a 10 trillion ton asteroid, okay, you'd feel a little bit of gravity, wouldn't you? It wouldn't be much. It'd be much less than the moon, but you feel a little bit of gravity. So if Antarctica loses 10 trillion tons of ice, which could happen in decades from now, it's going to have less pull on the adjacent ocean, a little bit less pull of the ocean close to the coast, just like that asteroid has a little bit of gravity. If you remove 1 trillion tons from Antarctica, sea level goes down near Antarctica. But what happens to that ice is it spreads out over the ocean away from Antarctica, because Antarctica is part of the Earth's gravitational field. We just took mass and took it away from there and put it into the ocean. What happens is that the coastlines of the northern hemisphere get more than their share of sea level rise overall. This pattern doesn't really show up right now in terms of what we're measuring in sea level rise. But when a meter of sea level rise has come off of Antarctica, again, in a century or so, that will be the general pattern that Antarctica is contributing to sea level rise. And what you're seeing there is, if there's 1 meter of sea level rise, how much will you get, in your particular coastline? Well, you can see there's a range up to 1.4 for areas like Australia and the east and west coast of the US. And then areas that are much lower, which happens to be right near the glacier where all of the mass was lost. So it's, ocean isn't being pulled against the continent as much anymore.
Thank you. A question, we were talking about diversity a moment ago. In terms of international relations, you have McMurdo, which is US, and then there's other bases of other countries. How do the countries, the independent countries, collaborate or cooperate, or is there, Russia goes to war? Is there an impact on what's going on in Antarctica in terms of other bases?
I can answer that. Okay. Well, first of all, the Antarctic Treaty is really the document that governs Antarctica in the present day. Before that, several nations had a claim to Antarctica. Most of the time they were shaped like wedges that extended to the South Pole and claimed a certain section of coast. And that section of coast would have either had a lot of exploration from explorers from that particular country, like Norway or New Zealand or Australia, all claimed sections of coast that they were more familiar with because their history was tied up with that part of Antarctica. In 1958, 59, the Antarctic Treaty was signed, and it said all you nations need to suspend your claims of actual making Antarctica become a part of your country. Antarctica will be reserved for scientific research. It won't be used as a military base. And we're going to review this every 50 years. And I think the first time was 90 or 40 years. First time was 91, and the next time is 2041. Russia has started a war. In general, Antarctica has stayed away from that kind of politics and is mostly a place of scientific cooperation, in part because of the treaty, and in part because scientists tend to look more towards collaboration with other countries and more work on the problem, which is independent of politics and stuff. And so, yeah, it really doesn't have much of an effect. I think in the future, as the world becomes hungrier for resources, it's going to be tough for the Antarctic Treaty to maintain Antarctica as no mining, no exploitation, no economic development. I would like to see that happen, or if it does happen, that it's very well controlled. Right now, there isn't too much pressure because it's too expensive to mine just about anything in Antarctica, because getting there takes a tremendous amount of work. But that won't always be the case.
And that's one reason why I wanted to write the book also. It's for 14 to 24-year-olds, although everybody's enjoying it, but to get young people understanding that they'll be the decision makers in 2041 and the mining is 2048. So to get people to understand as much as they can about what's going on so they can make a good decision.
Leilani, where's your book and how can you get it? It's on Amazon, I think, from what I saw.
Yeah, I am also one of the tattered cover Colorado authors, and they don't have the book yet, but they will. Yeah, it's like June or something that they're gonna do events. So yeah, you can find it. And I have a website, The Call of Antarctica, and that gives you some places also. Yeah.
There's actually, her dad literally was the first person of African descent. And there is a video of him swinging on a rope and landing on Antarctica because he's the guy they send from the ship to help rope the ship down against the ice as it arrives to set up the base in Little America. It's astounding to me that there's a video of this event and there he was.
I do.
Given that we have heard about global warming for a long time, relatively speaking, have we made any impact whatsoever? Are we going to escape any of these dire predictions, or are we doomed?
First of all, I wanted to acknowledge, and then I want to immediately deny that I had anything to do with it. Thwaites has been called by the media the Doomsday Glacier. You gave me an avenue to say that. I don't like that name because it does imply that there's nothing that we can do about it. Also kind of implies that it would be a sudden catastrophe like Doomsday. Have we made any impact? Frankly, no. The curve of how much CO2 is going into the atmosphere really hasn't bent off of the trend that it had up to now. Even COVID, which did lower CO2 in the US, didn't stop the overall rise globally. In Western Europe too, lowered it in Western Europe and the US, but it didn't stop the overall trend towards increasing greenhouse gases. Now, are we going to avoid the trend in the future and these disasters? And I think we really will. I think we will because you can tell, if you think about it, that there is a lot of economic energy behind solving this problem, that people recognize that this is going to be a factor in the future economics of the US and the world, and they're building to address those challenges, those needs. Renewable energy, electric cars, biofuels, all of these things are seeing a surge right now. The most, what the biggest automobile company in the world by investment is Tesla, because people know that electric cars are the way of the future. They don't really solve the problem. Electric cars take a lot of carbon to build in the current economy, but we're going to start more and more with steel mills that work on renewable energy. I believe the steel mill that's being restarted in Pueblo is going to use a lot of renewable energy. That's the path of the future, is when it becomes an economic challenge and an entrepreneurial challenge to the economies of the world, and in particular, the US economy. If you set the US on a challenge like that, and I'm going to say it not really as a joke, it was just, and there's money involved, you can bet that there will be 10,000 people lining up to figure out an answer. That's my hope for the future.
But there's also India and China.
Yeah, and they'll follow.
We can't control, I don't know, you know.
And they'll follow when the technology is there and when it's actually cheaper. I do too.
Two short questions. One is, how much precipitation does Antarctica get every year? And then second, would you just compare and contrast a little bit the Arctic with the Antarctic in terms of how they're manifesting climate change and just their overall loss of ice, et cetera?
Okay. How much snow falls on Antarctica? In total, if it means anything to you, about 2,000 billion tons per year falls, and about 2,200 billion tons it is removed by ice flow. Well, I said 150, 200, it varies from year to year. Outflow versus input with snow. 2,000 input, 2,200 output. That's Antarctica. So it's losing mass. Now, compare and contrast the Arctic.
Just one second. What I meant really was how many inches of precipitation. I understand that it's a dry area, but obviously it gets some snow. So just compared to, like, you know, Denver, for example, 13 or 14 inches a year. That's what I was getting at.
That's a huge amount for Antarctica, but around the coast, there are places that get up to 30 inches of water, but in the form of snow. So it's 8 times as much or so. initially. Around the coast, it can be really wet and snowy, but most of the interior is the driest desert continent on Earth and gets less than 2 inches of snowfall. That high East Antarctic plateau, the big oval area that kind of compared to Australia, 2 inches or less over most of that. But around the coast, lots of snow. And that's also where the glaciers flow the fastest, so the snow gets unloaded quickly. But yeah, that's the general picture. Comparing and contrasting the Arctic and the Antarctic so far is losing ice. It's losing a relatively small percentage of ice, considering how large the ice sheet is at this point. And sea ice, the ice floating around Antarctica, which we think would be very responsive to climate change because it's thin and it doesn't take much additional warmth to melt it away, is just jumping around all over the place from year to year. It's very variable, that the storms and the ocean currents around the continent are just pushing the ice around, and it's not really shown a trend that's related to climate yet. And in the Arctic, things are headed downhill in a hurry. The sea ice around the Arctic is about 60%. It's lost about 40% of what it was in the 50s and 60s. And in particular, the whole Siberian coast of the Arctic sees a lot less ice, a lot longer open water period. And that is being exploited, not just by Russia, but especially by Russia, but also by Europe and Japan trying to get goods and services, goods across the what's called the Northeast Passage or the Northern Sea Route. Greenland is losing more, is a much smaller ice sheet, and yet it's losing more ice per year, about 250 billion tons, because its glaciers have begun to accelerate. But more importantly, Greenland has a summer that's warm enough that direct runoff of water off this ice sheet turns blue for hundreds of miles, and there's just rivers running off of it into the sea. That has picked up in the last 3 decades, and now that's about half of the total loss. 250 billion tons total, more than 100 billion of that is from direct runoff from melting in the sun, basically. So in the Arctic, there's no question about what trend things are going in. And permafrost is thawing, and sea ice is much thinner and much less extensive than it used to be. And Greenland has changed tremendously. In the Antarctic, we're still just seeing the early scenes in the play, so to speak. We have a long way to go, but we know enough about how ice works to know that there's real potential for well, a very slow moving catastrophe that would come from this continent.
Anyone else? I think supposed to wrap it up pretty soon here. So if there are any other questions, please ask them. Otherwise, I want to thank you so much. Thank you. Is yours still on? All right, well, that was really eye-opening. And just so everybody knows, it's called The Call of Antarctica. There's a copy up here. Leilani Henry, who spoke here tonight. I'm excited to read this. But I wanted to, first of all, thank you for your presentation tonight. And I want to thank everybody that came tonight. I think we all got a lot more information tonight. Sometimes we're speechless because we have so much information downloaded. But the other thing I'm going to tell you is we're very busy, the DCFR right now. We have meetings coming up quite frequently in the near future. We have a busy April, for instance. On the 6th of April, in just 2 weeks, we'll have William Drozdiak. He has a book about Emmanuel Macron. It's called The Last President of Europe. And I'd really highly recommend maybe taking a look at that book before the meeting. And also it is an excellent book and he's an excellent speaker. We also have a lunch scheduled with Dr. Linda Barrientos to talk about water rights and water access. Leilani, you might want to be a part of that because interesting conversation on equities and other things related to water and access to water. Very important topic, and she's dedicated most of her life young life to that. We also have I guess the award, which I haven't told anybody about, for our Global Engagement Award this year. It's going to be in May, and the president of the Denver Botanic Gardens will be receiving the award this year. He'll also be sharing their facilities for us for the meeting. And we're very happy to announce that we have the dinner at the gardens there. So everyone will be able to see the gardens as well as the new Freer Newman building and art galleries. Again, art. So really looking forward to the next few months, and we're building an excellent schedule for next year. We have speakers like the speakers we had tonight that are just superb and outstanding. And I really appreciate everybody being here. I know that you know that we have excellence with what we strive to get as speakers, and we've always tried to provide the best. So without further ado, I ask you, take a look at our website, look around, ask people questions, and I look forward to our next meeting and getting together again. Thank you. Have a good evening.